Bismillahirrahmanirrahim. We are studying chapter 5, that is brake system. We have already covered the first part of brake system. Today we will study the second part. We will cover this chapter in 4 parts. So first, a quick recap of the first part, the main slide which we are of this course of automotive technology. Then we talked about the brake and what brake system is designed to reduce the speed, stop a moving vehicle, to keep it from moving if the vehicle is stationary. Then we have discussed the block diagram of the complete brake system in a vehicle, from foot pedal till the disc brake in the front wheel drive and the rear drum brakes till completion. And then we talked about the disc brake in detail and the drum brake. So we talk about the drum and disc brakes. Then I have already uploaded these videos for your better understanding. Then we talk about the brake design requirement. And then the brake system category, how we can divide the brake system in a complete 6 subcategories: supply system, boost system, hydraulic system, wheel brakes, brake balance control system, and brake warning lights. Then we talked about the drum brakes advantages, the self-energizing and servo action parking brakes. Then the disadvantages of the drum brake and brake fade. And in fade, we have 4 types of fades: mechanical fade, lining fade, gas fade, and water fade. Then brake adjustment and brake pull. Then we talked about the different parts of the brake, drum brake, then non-servo brake design, and brake hydraulic system. And we talked about the brake master cylinder, which is the heart of the entire braking system. Today, our part 2 lecture of this chapter is mainly focusing on this brake master cylinder. So as we know, it consists of 2 main parts. The upper part, the reservoir part, is made of plastic material, and the body part, the lower part, is made of the aluminum. So I have briefly explained the function of this brake master cylinder. Now, again, for your better understanding, once again, this is the end where we get force or pressure, foot force. When we apply a foot pedal, from foot pedal, the force goes to the vacuum booster or power booster. From power booster, that force is applied here on the master cylinder. And in master cylinder, we have this piston here and this piston here. And there are 2 openings. The nearer one, this master cylinder is the location of the master cylinder in your vehicle is in engine compartment, and it is attached with your bulkhead. Bulkhead is the separation between the engine compartment and the passenger compartment. The wall or the frame which differentiate between the engine compartment and the passenger compartment, that wall is known as the bulkhead. On a bulkhead, it is attached with your vacuum booster or power booster. So the nearer vent or the nearer outlet is the fluid is going to the front brake, and from the furthest vent or the outlet, the fluid is going to the rear brakes. And these are the vent holes and the replenishing hole. We have studied this thing. When we apply a force, it blocks the vent and pressurize the fluid here in this portion. And the spring is compressed, so that compressed fluid goes to the front and the rear brakes. And we get the replenishment in this portion and in this portion, and fluid from the reservoir seep in this portion and in this portion. Now the replenishment port is brake fluid is coming here. It fills that area and it is going to this side. like this. Okay. So up till this we have studied in our last lecture. Now let's see the brake proportioning. We have three types of brake proportioning: hydraulic, mechanical, and electrical. This is the lower part of the brake master cylinder, which is made of aluminum. Here is the master cylinder body. This portion where I moving my cursor, the pointer, it is attached to your vacuum booster or the power booster. From here, we apply a force. This is the nearer outlet and this is the furthest outlet. So there is a difference between the thread dia of the farthest having a 10 mm thread dia and the nearest having a 13 mm thread dia. And the proportion, these are the proportioning valves, and their dia is different. So many proportioning valves are mounted directly to the master cylinder in the outlet of to the rear brakes. Now, if you remember the first figure which we have seen, this one. Here you have this master cylinder and this is the reservoir. And this assembly is the combination valve. Here, it, in previous vehicles, it is separately mounted, but in latest vehicles or the modern vehicles which we are using nowadays, this master cylinder is having all these valves. Okay, so many proportioning valves are mounted directly to the master cylinder in the outlet of the rear brakes. Okay. What is proportioning valve? Purpose and function. A proportioning valve improves brake balance during hard stops by limiting hydraulic pressure to the rear brakes. Let's imagine you are moving at a high speed and we apply a brake. And the master cylinder here having no difference in the outlet thread dia, it's of the same. The fluid pressure develops here and it goes to the front and the rear. Now, this is in the engine compartment and the distance between from this master cylinder body to the front wheel is very less as compared to the distance from this master cylinder to the rear wheel. Rear wheels are in basically at the end of the passenger compartment or the rear seat or near the trunk or the luggage where we place. So the distance, and if the pressure is applied at the same time, we apply a pressure on the brake pedal. So the front wheel will stop first and the rear wheel will stop at this at some with some gap. So the pressure is not applied at simultaneously. So we want that it should be applied as at one time. At when we apply, so both should act at one time. But that is also a problem. So because the weight dynamic weight is moving in a stationary vehicle, the weight is on both the front wheels and the rear wheels. But when we are the there is a dynamic weight. So the vehicle is moving. We apply a brake. So the inertia or the weight will try to shift on the front axle from the rear axle, and rear axle will try to lift up. So we have to balance that inertia also. We have to balance that the weight shift. So the proportioning valve are designed in such a way that the front brake should engage first with few milliseconds and then the rear brakes. So a proportioning valve improves brake balance during hard stops by limiting hydraulic pressure to the rear brakes. A proportioning valve is necessary because inertia creates weight shift towards the front of the vehicle during braking. We are moving at a speed, so a vehicle or a body is moving with a speed. So when we stop it, so its weight shift towards the front side. So to avoid that topple or to skid or to overturn, we require some mechanism to have that balance. That balance is provided by the proportioning valve is necessary because the inertia creates weight shift towards the front of the vehicle during braking. The weight shifts unload the rear axle. So when the brake is applied and the weight is from the rear axle is shifted from and it's unload the rear axle, which reduces traction between the tires and the road rear wheels and limits the amount of stopping power that can be delivered. Unless application pressure to the rear wheels is limited, the rear brake will lock. So, unless application pressure to the rear wheel is limited, the rear brakes will lock, making the vehicle unstable and likely to spin. So, the best overall braking performance is achieved when the front brakes lock just before the rear brake. So, it is in milliseconds. So the best overall braking performance is achieved when the front brakes locks just before the rear brakes. Vehicle with front disc and rear drum brakes require a proportioning valves for two reasons. So the front brakes are disc brakes and the rear brakes are drum brakes. So that vehicle which having a front disc brake and rear drum brakes require proportioning valve for two major reasons. First one is the disc brakes requires higher hydraulic pressure for a given stop than do drum brakes. So because of their construction and their properties, disc brakes requires higher hydraulic pressure for a given stop than do the drum brakes. In disc oblique drum system, the front brakes always need more pressure than the rear brakes. Meaning of this explanation of this point is we are having a vehicle in which the front wheels are having a disc brake and the rear wheels are having a drum brake. So the front brakes always need more pressure than the rear brakes. Once braking has begun, brakes requires less pressure. Now the we have pressed the pedal and the braking action has been started. Once the braking has begun, the drum brakes requires less pressure to maintain fixed level of stopping power than they did to establish that level. So initially they require more pressure, but that is less than the front disc brake, and that small pressure will be further minimized when we have the braking operation has begun. In a disc oblique drum system, the rear brake will always need less power than the front brake when we have first there is a pressure difference. The front disc brake requires more pressure than the rear disc brake. Let's suppose if front disc brake pressure requires certain psi, the rear brake will require lesser psi. And when this braking operation started, that pressure is continuously not required. Even we require less pressure to maintain the braking action. The proportioning valve does always not work. Remember this thing. During light or moderate braking, there is an insufficient weight transfer to make rear wheel locking a problem. So it is not always work because in the light or moderate braking, there is insufficient weight transfer to make rear wheel locking a problem. Before proportioning action will begin, brake system hydraulic pressure must reach a minimum level called the split point. Split point, we are moving, the hydraulic pressure has to be built up so that it should reach a minimum level, and that minimum level is called the split point where the pressure is changed in the front and the rear. Brake engineers refer to the ratio of the front to the rear brake proportioning as a slope. So one is the split point and second thing is the slope, and that slope is the ratio of the front to the rear brake proportioning, pressure proportioning. Now this figure, a Chrysler proportioning valves Note that slope and split points are stamped on the housing. So here they are stamped. Slope, oblique, split point. Let's see what are those. Now, for full system pressure to the rear brakes equals, let's see the first graph. On our x-axis, we have this input pressure, which we are applying by pressing the pedal. This is in PSI, 100 and gap of 200. Now on the y-axis, we have the output pressure, which is coming from the brake master cylinder, which are having the proportioning valves. So we apply a pressure, hydraulic pressure in this system. Here, this is the point where it is split. The front brakes having a higher pressure and the rear brakes are having a lower pressure. Okay. We are applying the same input, but with the help of this proportioning valve, it is splitting at this point, somewhere here at 200 psi inlet pressure. Okay, it is splitting. The front brakes are having the same pressure with the same ratio, but in rear we are having lesser pressure. So this is the split point where the pressure in the both systems differs. Then in the rear brakes, we have this slope. On x-axis, this is the 200 and by 100. Look, if slope is 100 by 200 means 0.5. Let's see. Full system pressure to the rear brakes equals a slope of 1. If we have a full system pressure, means 100 by 100, then it is a slope of 1. But if only half the pressure is allowed to reach the rear brake, so if half the pressure is allowed to reach the rear brakes, the proportioning valve is said to have a slope of 0.5. So the proportioning valve on most vehicles have a slope between 0.25 and 0.5. So this is the range in which the proportioning valves maintains the pressure in the rear brakes. Typical proportioning valve pressure relationship. Note that at low pressure, the pressure is the same to the rear brake as is applied to the front brake. So at low pressure means at 200 psi in front and the rear brake, it is same. After the split point, after this 200 plus 200 psi, it splits. Only a percentage called a slope of the master cylinder pressure is applied to the rear brake. So whatsoever the dia or the proportioning valve you are using, that proportion of pressure is applied to the rear brakes. Now let's see. The proportioning valve piston can travel within the range shown without reducing pressure to the rear brake. So this is your master cylinder and this is the valve which is going to the rear brake pressure. So this space, this is the travel which is piston travel before the valve is closing. This vent valve is closing. This is your green is your piston and this is the rod and with spring. So we are applying a pressure here. This is the body and this is the only space available for the piston to travel. Now, when the piston is moving back, it's open the vent at the split point. The proportioning valve piston closes the fluid passage through the valve. Now let's see what is electronic brake proportioning, parts and operation. Electronic brake proportioning is used in ABS system, the anti-lock braking system. If our vehicle is equipped with this electronic brake proportioning system or ABS system, the anti-lock braking system is accomplished by monitoring front and rear wheel speeds and reducing pressure to the rear brakes as needed using the ABS solenoids when there is a difference in the wheel deceleration rate. In the next part, the third part, I will cover the anti-lock braking system in detail. But just to give you the idea, when we are using the anti-lock braking system, all the four wheels are equipped with sensor, and those sensors are monitoring the speed of the wheel, and they are giving continuous feedback to the engine electronic brake system, and the brake system, the computer ECU, the engine control unit, or the electronics of that vehicle is monitoring that pressure and monitoring the speed, monitoring the pressure, and they, when the brake is applied, they apply in proportion to that speed and pressure. Electronic brake proportioning in the anti-lock braking system is accomplished by monitoring front and rear wheel speeds and reducing pressure to the rear brakes as needed using the ABS solenoids when there is a difference in the wheel deceleration rates. The controller energizes the inlet valve solenoid for both rear brakes to hold pressure in the line, and then energizes both rear outlet valve solenoids to release pressure as needed. So basically the ABS, the electronic system control, the controller energizes and de-energizes the solenoid valves to maintain that pressure in the system when we apply the brake. The dynamic rear proportioning function is enabled at all times unless there is a failure of the anti-lock brake controller or two-wheel speed sensor on the same axle both fail at the same times. If your sensors and solenoid malfunctions, then we have this phenomena. But as long as there is at least one functional speed sensor, if instead of both the wheel sensors are faulty, or then we have this dynamic rear proportioning function is enabled. But if one of the sensor is working, then on the front and the rear axle, the anti-lock brake controller can compare the relative speed of the front and the rear and then apply the pressure for the braking system. Now, the second thing after the proportioning valve is the metering valve or hold-off operation. Metering valve is used on all front disc and rear drum brake equipped vehicle. The metering valve prevents the full operation of hold-offs the disc brake until between 75 to 125 psi is sent to the rear drum brakes to overcome the rear brake return spring pressure. So it meters the pressure front and rear. This allows the front and rear brakes to apply at the same time for even stopping. Most metering valves also allow for the pressure to the front brakes to be gradually blended up to the metering valve pressure to prevent front brake locking under light pedal pressure on icing surface. So I read again. This means this pressure range metering valve. This allows the front and the rear brakes to apply at the same time for even stopping. Most metering valves also allows for the pressure to the front brakes to be gradually blended up to the metering valve pressure to prevent front brake locking under light pedal pressure on icy surface. Now, system without metering valves. Braking systems that are diagonally split means such as those found on most front wheels drive vehicles do not use a metering valve. So diagonally split means right and front right and rear left, front left, rear right. So braking systems that are diagonally splits, such as those found on most front wheels driven vehicle, do not use metering valves. So they do not use metering valve. A metering valve is only used when the front oblique rear split braking system, such as those found on most rear-wheel drive vehicles. So metering valve is only used on front oblique rear split braking system when we have a front separate and rear separate braking system, such as those found on most rear-wheel drive vehicles. There are three reasons why front-wheel drive vehicles do not use metering valves. Means the diagonally split vehicles we do not use metering valves. Why so? Front wheel drive vehicles usually have a diagonally split dual braking system that would require a separate metering valve for each hydraulic circuit. So a diagonally split dual braking system require a separate metering valve for each hydraulic circuit. This would make the brake system more costly and complicated. So we do not use in diagonally split braking system vehicle equipped with. Front wheel driven drive vehicles have a forward weight bias that requires the front brake to supply up to 80% of the total braking power. Since the front brake do most of the work, it is desirable to apply them as soon as possible when the brake pedal is depressed. A metering valve would create a slight delay. So the front wheel drive vehicle have a forward weight bias. So due to that forward weight bias, that requires the front brakes to be supply up to 80% of the total braking power. Since the front brakes do the most of the work, it is desirable to apply them as soon as possible when you press your brake pedal. A metering valve will create a slight delay or gap. So we do not use on the diagonally split or the front wheel driven vehicle. Until all the clearances in the brake system is taken up, there will not be enough pressure in the brake hydraulic system for the front disc brake to overcome the engine torque applied to the driven front wheels. So third reason is until all the clearances in the brake system is taken up, there will not be enough pressure in the brake hydraulic system for the front disc brakes to overcome the engine torque applied to the driven front wheels. So that's why we do not use metering valve in the front wheel driven vehicles because of the diagonally split system. Now, the third thing is the combination valve. Most vehicle manufacturer combines the function of a proportioning valve with one or more other valves into one unit called combination valve. So proportioning valve is there, but we use some other valves also. So one typical rear-wheel drive vehicle or typical combination valve consists of the following components all in one replaceable unit. That is metering valve, proportioning valve, and pressure differential switch. Let's see. So this is your proportioning and pressure differential, and this is the switch terminal. And here it is metering pressure differential, typical two function combination valve we are using here. So on a typical rear wheel drive vehicle, a typical combination valve consists of following components all in one replaceable unit: metering valve, proportioning valve, pressure differential switch. Some combination valves have only two functions and it contains the pressure differential and the metering valve, while the other combines the pressure differential with the proportioning valve. It depends upon the OEM which type of combination he wants to use. Either it's a pressure differential with metering valve or it's a pressure differential with a proportioning valve. Now, the last part of this part 2 is brake fluid and rubber parts. Hydraulic plays very important role in our brake system nowadays. Your master cylinder contains the brake fluid, and that brake fluid is in reservoir in master cylinder sleeve and then going to the brake lines and then applying that pressure to the disc or the drum brakes. And in wheel, we have a wheel cylinder. So it contains the brake fluid must be such that it should not freeze, it should not evaporate, and it should withstand with high temperature and extreme temperatures. And rubber parts are should be such that they should not perished with easily. They should not be too stiff. They should not be too hard. They should perform there with function with the tolerances given to them in, and they should not wear off easily. So all the rubber parts and the brake fluid has to be maintained and periodically checked. So with this, we comes to the end of our part 2 of chapter 5 lecture. So next part, we will be covering the ABS system in detail.